All right, so the 6 strong monoprotic acids. Monoprotic, it means that it has one ionizable hydrogen. That's what monoprotic means. And there's another question in here about monoprotic, diprotic, and so forth, okay?
Number 8.
So the strong monoprotic acids are hydrochloric acid, hydrobromic acid, hydroiodic acid, and those are the 3 binary strong ones. Then you have nitric acid, you have chloric acid, and perchloric acid. Okay? Then there was one strong polyprotic acid, and that's H2SO4, sulfuric acid, yes. The 2 weak acids you need to know are carbonic and phosphoric. And the reason we ask you to know those is because those are very important in maintaining the pH in your body.
Yep, that's right.
Yep, that's it. Okay. Let's see.
Can I get some water?
Yes. The 4th. What? For what? Either one works. Bronsted Lowry or Arrhenius works for that. Okay? Guys? Shh. Alright, the remainder of the question, number 4, the 4 strong bases.
4.
There are 4 strong bases. Sodium hydroxide,
5.
4 strong bases. There's 1 weak base. 4 strong bases. The strong bases are sodium hydroxide, potassium hydroxide. I don't have my references in front of me, but calcium hydroxide and barium hydroxide. You're supposed to know that, yeah.
You told me how to know this for the test?
Yeah, would you like me to show you where I did the notes the other day? It was on the notes.
Yeah.
Put in the notes that we have.
If it's in the notes, you're supposed to know it. Okay? Now, then there's only 1 weak base, and we work with this weak base a lot. That's ammonia. Okay? Ammonia. Was that all of number 5? Okay.
So those, the NOH to the NH3 is weak, right?
These are all strong bases.
What's the top of the weak base?
These are the strong acids. These are the 2 weak acids you need to know. Strong base you need to know. The 1 weak base you need to know. Yes. Sure.
Acids end in H. No, acids end.
Acids begin in H. Bases,
end in H.
the strong bases end in OH.
Strong bases end in OH.
Correct. All right, number 18. Determine the pH, pOH, the concentration of hydrogen ion, the concentration of hydronium ion, and the concentration of the hydroxide ion in 0.0100 molar hydrobromic acid solution. Okay? All right. Here we are. Strong acid. Okay? So if it's a strong acid, what does it do in water?
It ends in OH and it dissociates.
Not in OH. You're talking about strong bases again. A strong acid dissociates completely, and you get as many hydrogen ions as you had acid. So in water, HBr, dissociates completely. That is what, by definition, makes it a strong acid.
How do you know if you do the Arrhenius or the other one?
Well, since it's asking this, if it's asking for the hydrogen ion concentration, that's Arrhenius. Bronsted-Lowry is this, so it's really asking for both. But you really need to know that this concentration equals that concentration.
You can automatically does the same answer without having to do work.
Correct. Okay? So, if we have then 0.0100 moles, it's molar, right? Molar, okay? Molar of this, then all of this is going to go away because the HBr dissociates completely. We're not going to have any of that left. And what we're going to have then is a solution that is both 0.0100 molar in the hydrogen ion and 0.0100 molar in the bromide ion. Okay? Therefore, we already know now that the hydrogen ion concentration is this. And if the hydrogen ion concentration is this, then the hydronium ion concentration is the same. Okay? If we move the decimal place 2 places to the right, we get an answer that is 1.00 times 10 to the negative 2 molar.
Can we have a free week next week?
So that you can see what the exponent is. Because if I have 1 times 10 to the negative 2, then calculating the pH doesn't even require a calculator. The negative logarithm of this, a logarithm is an exponent, so it's 2, and the negative logarithm means the negative part means we change the sign.
So the logarithm would be 2?
pH equals negative logarithm. Not, the logarithm will be negative 2. The negative logarithm is 2.
12 is pH? 12 is pH?
pH is 2.
How?
That's a 2 right there.
So
So the POH would be 12.
The pH should be 12. What?
So we always do the decimal behind the first number that's on 0?
Well, you're not required to do that, but I'm just showing you that if we do it that way, you can see from the exponent where you get the logarithm from.
Okay.
Trying to make it kind of a little bit simpler for you, okay? Yep.
If I get 300 homework, will that down sound bad too?
That would depend on how many total number of homeworks you have.
Like, I'm saying, like, if I get 300 back to back.
I do not know the answer to that question. All right. Let's see. Now, then if the pH is 2, and if 14 is equal to pH plus POH, please stop doing that, please. Then the POH must be 12. If the POH is 12, and the hydroxide ion concentration is 10 to the negative POH, then the hydroxide ion concentration is 10 to the negative 12. Okay? I can calculate POH this in 2 different ways. I could use KW equals hydrogen ion concentration times hydroxide ion concentration, and KW is 1 times 10 to the negative 14.
Start it up.
Molar squared. If we know this number and we know this number here, we can plug it in and get the math that way too. Okay? What essentially is going to happen is this exponent here, you can take this exponent, subtract that exponent, and you'll get 10 to the negative 12, which is what we got right there.
That's easier the other way. Just don't leave KW alone.
All right? Okay?
I don't even look
But
at
there are a couple of ways to get the answer. Okay? All right. Any other questions?